Bear with me, I'm not quite here yet. But thank you for joining me. Alright, I'm here. Getting into my perch. My wife texted me last minute to, can you throw the laundry in? I'm like, okay. I guess I can do that. Alrighty, where am I? I'm here somewhere. Ah, there I am. Welcome, welcome. Let's see, what else is available on my stuff? So I don't need this. I guess I can keep all that stuff up. I will refresh this thing. I can close this stuff. Refresh that. Okay, and we should be in my oof. Yeah. Alright, so before I jump into tidying up the code, I wanted to make this little wall-mounted thing for the crank box, right? Maybe at some point we'll do the animations for that, but yeah. And you guys can hear me, right? Volume's working, hopefully. Sound looks like it's working. Alright. Alright, so what I've done here is I've grabbed a cube and I scaled it down to an appropriate size. And then for the cylinder, I'll just show you how I did that real quick. So I made a cylinder. Boop, come here you. And on the first cylinder, I just took the subdivisions down to 6 to get that shape. And then make a duplicate of that. And then on the other one, I put that back to 20 And then you size them up however you like. I'm just going to scale. And then I'll just scale that one a little bit more, scale it down. Center them both. However far you want it. You can cut all the way through or you can cut partial. I'm just going to cut part of the way through. Actually, I'll just do it this way. Like so. Clear the history on them before you do anything special. And then you take the thing that you want to keep, the thing that you want to get rid of, and then you do a Boolean operation under mesh, and then difference. And then it will cut for you, which is nice. And if you don't want to keep the current design, you can always take your object and move it, and it'll do a live update. Live Boolean is really nice these days. One of the few improvements in Maya that I really enjoy. And then once you're happy with whatever shape it is, you take the whole thing and then you remove the history on it, and now it's permanent. Cool. So I did that for this object, and then I put a cube under it. I'm going to live Boolean, I think, one more time just to merge it down. But realistically, I don't have to. I can totally keep this as two objects pressed into each other. It's just bad design to do it that way. So since I try to hold myself to good good practices, I'm going to try to union this thing like so. That way I can strip away anything I don't need. And then I will clear the history on that, make it permanent. Yes. And here's the object. Now, there are some caveats about doing a live Boolean like that, and it's very, very messy. So this is an illegal shape. Remember that n-gons are a no-go. Unreal will deal with n-gons. I actually think it converts everything to triangles. But be that as it may, or however you said it, be that as it may, you should take the model you've just made, and you should triangulate, or you can try to quadrulate, but usually that doesn't come out as nice. Triangulate, that way you can not have a big mess of n-gons. And that breaks this into a set of triangles and or quads. Okay. Now we have a shape that's mostly legal. Well, I mean, it's technically legal. And then I got the UVs on it. Here's this wonderful thing. Let's just do an automatic. That actually isn't terrible. I'm not mad at that. All of the pieces are defined. We have the front face, we have the center. And all those. Okay. Yeah, like that's very much doable. I don't need to do anything special on it because I'm just going to make it one solid color anyway. Perfect. And then for the color of this thing, because I don't want to waste too much time, I'll go to rendering. I want it to be somewhat shiny. So actually, I'll just do the shininess inside of Unreal. I'll just drop a Lambert on this. I'll call this, what is this? Crank box. Texture. And then whatever color I want it to be, I want it to be kind of like a bronzish color. I could probably pull up the color code for bronze or brass. How about copper? Copper RGB. There we go. That's a good one. So I can change this down to, let's do RGB. And Actually, does this accept a hex color? It does not. Hex color would be nice, but I'll just take the RGB. So we have red 184. Green 115, and then blue 51. I know it looks weird, but Maya tends to render things out with a slightly different color scheme. So if I put this inside of Unreal, it'll probably look fine. So I'll take that. I think that's a good size for it. I can scale it in Unreal. I just like to have things to be the proper size. But I'll do this as crank box. Let's get rid of anything speckle. And then I'll set this to center. Yes. And I will position it so that it is on the grid. Like so. And I don't need a backside to this thing. I can totally cut the backside off. But I'm not going to. Mainly because I'm being lazy, but also there could be a situation where like that wall breaks and pieces fall off and whatever not. So since I know that's not going to happen, it doesn't matter, but whatever. For now though, I will export this. I'm in 3D printing. Where's my scenes? And where's the... Do I have a Resident Evil folder? What was I doing this in? Tutorials? Maybe it wasn't in tutorials? Oh, let's try FBX. There we go. And then it's going to be SM for static mesh underscore crankbox. Cool. And then I can jump back over to the code, and we can kind of put that into there when we get going. So let's go ahead and just fire this up, make sure the things load. So the goal here is to try to finish up all of the remaining coding bits. There's a lot to do, but I think I can do it in the next 2 hours. I have a friend who wants to come over at 3, but it's kind of chilly outside, so I might cancel. I know, it's Florida and it's chilly. Weird. Anyway, we left off where if I hit play, I can move forward and back, and left and right. Let's see. Sorry, I'm looking a thing up because I want to get rid of that bloom effect, and I forget what it's called. Anyway, that's not that important. It just kind of bugs me when I go into the room and everything dims and whatever. It's a neat effect, but I like to turn that off. Anyway, so that works. We have this stuff is in here, and we need the crank box, which is here. And actually, I'll just bring in that object. Where am I at? Documents, Maya, projects, default, scenes, and then tutorials. And we want the crankbox. There you are. Drag that in. Import. I did bring it into the wrong folder, but it's okay. I'll just drag these into their appropriate folders. This one to materials. Move here. And then this to static meshes. Move here. Cool. We'll save all. For the material, let's go ahead and do a very quick adjustment on that. I want this to be metallic, so in here, let's make a constant value for metallic. Just drive it into here. What do I want this to be? About 7.5, I think. Looks pretty good. For specularity, let's pop that into there as well. About half. Roughness. This is where we're going to get really the polished look on here. I'm gonna pop that into roughness, and I will reduce the roughness to like 0.1. Oh, it's way too polished. Maybe 0.25. Yeah, it looks a little more metallic. And I can always adjust this to make it somewhat darker. Lean more into the red. Lean more into the dark. There we go. Love their material editor. It's pretty awesome. Okay, so I'm going to jump into the blueprint for this thing. Environments, crankbox. And inside this blueprint, I'm going to remove all the blueprinted stuff that we did before because we're going to code everything. So I'm going to get rid of that. I'm also going to get rid of these variables. I don't need this wall variable or the Boolean. These I'm going to keep for just a moment because I'm going to use these as a reference as I build out the coded portions. Now you do not have to code this. You can totally do this visually here. However, if you want to talk to any of this stuff in code, you're going to have to create variables for it and make sure that you drop them into those variables. And I'll show you how to do that as we get going. So before that, I just want to see how this crankbox is going to look. So I'll pop that in, and it's in position, but it needs to be rotated a bit this way. And then as far as scale is concerned, I'm going to throw it into world, and I can get an idea of what it will look like. I somehow made 2 of them. Let me Control Z. There we go. Let's move this one into here. This is the, yeah, that's the wall. I'll grab you in position here. And I want that to be right up against the wall. Let's do, where are my snaps? Add down to 1. I think that's good. Okay, so in world, it's about that big. And so I can scale that up. Right now it's at 0.5 scale as default. Let's change that to 1 by 1 by 1 and see if we got a good size there. And I'll also change the material on this thing. For some reason, the default material did not show for that, so I'm just going to pop that in. How big is that relative to the character? I think that's pretty good. I could do some other things to make it more pretty, but it's fine. It'll work for our needs. Okay. So that's good and that's good. Let's go ahead and save all that. And then I think we already created the object for those, right? So the C++, go to environment. Yep, I've got the objects for this. I do need a C++ object for my animation instance. So let's go ahead and make that. So C++, new C++, and I want an animation instance. So anim instance. This is going to be the RE animation instance, and that's going to go into the animation folder. Yeah. It's certainly taken a minute. Thought my phone was ringing. There we go. That took us a bit longer than anticipated. Let's go ahead and reload all. Alrighty, so as usual, it auto-adjusted the address of that, so I'll just change it. And then I'll go ahead and reload. Okay, so we do have the interface, we got that, we got that, we got that. Okay. So I think we're just about ready to bust out all the code. What part to tackle first? I think we should adjust the character and get a camera in there so we can see what we're doing, and maybe make it fancy when she walks. That's still loading. Yeah. There it goes. I can turn off the GitHub. I don't need that. All right. Now, one more thing we should do is for our crank box, we need to change the parent class. So up here under class settings, the parent class is currently the actor class. We want this to be our crank box. So RE crank box. Save that. I'll do the same thing for my rotating object, this guy. I don't think it has any variables or anything in here. No, it's all good. But I'll do the class settings and we'll make this the rotating wall. And save that. What that's going to let us do is when we write our code to it, it'll inherit those values. And then the character already has all that stuff. Yeah. Okay, so we can jump out of there, jump back into here, and we have our animation instance. So we want this to talk to our character. Let's go over to animationInstance.h, and let's see what we got. Let's create a constructor. So the constructor is just, because if you're doing C#, you probably don't ever deal with them. It's just the name of the class written as a method or a function. So this is going to be URE animation instance, like so. Let's see. And I'm going to put this in a public section. Alright, so now we need some variables. I'll go ahead and just quick create. That way it implements it here. So we need a U property for our variables. You actually don't have to do U properties. So a U property exposes those variables to Blueprint or to other aspects of the engine. It also adds it to the garbage collection. So it's just handy. Let's see. Okay, so we're going to need a reference to our player. And what did I make this? Edit anywhere. So edit anywhere, blueprint, rewrite, and category. What category did I set? I just called it player. And then this is going to be our RE player. So we're going to do a forward declaration. We're called class ARE character. And we'll call this RE player. And this needs to be a pointer. So we're going to do a little asterisk. That can be a bit confusing, so if you've never really dealt with pointers, and typically in C# you don't deal with pointers because pointers can be a bit dangerous. So the little asterisk is just, instead of multiplying, it's just saying, hey, I am being a reference to that thing, so I'm pointing to that. Let's see, what else do I need here? Oh, actually just my move speed. So another U property. Again, this will be an edit anywhere. And then blueprint, read. I think I have this set to read only. Actually, I have it set to read right over there, but it's okay. To make this a bit faster, I did already do all this work to. As fun as it is for me to fumble around, I didn't want to spend the next 3 weeks fumbling around on camera. I figured I'd take 3 hours and just do it. But because I do it on camera, I have to, or do it on video, it just takes longer, right? It might take me 2 hours on the video, and then I do something else and whatever. Whatever not, so it's all right. This is also going to be under the player category. And this is not a class, this is going to be a float. I'll just call it move speed. Alright, we have a protected section. Protected. So if you're not familiar with the private, protected, and public, public is anybody can access. Private is only the class can access, and then protected is only the class and its inherited members can access. Let's see. So I've got a couple functions over here. Oh, I can't quite see. I'm blind. Yeah. So we were doing a virtual void native. Begin play. Like so. Now, if you're wondering where this comes from, so normally we have a begin play, but if we go to our documentation, I have all the documentation up here. This is what I've been digging through the last couple hours. Where is the animation instance? Yes. So in here, you can get a list of, if you go to if you Google, UE5 animation instance C++, it'll take you to the document page for UAnim instance, and you can look at how it's broken down, what includes need to be added, what the class definition is, and then its general variables that are available and its functionality. So down here under, you'll see the constructor. This is what it constructs. This is the destructor. We don't really use them in C#, and I think they're pretty much obfuscated these days in general, but there is a destructor here. That's for garbage collection. It destroys it at the end of its life. Anyway, so the functions that are in here, these are all of them and what they do and some general stuff. Now, Unreal documentation is not that great. It will tell you the bare bones of how something works, but that's it. So, for example, you have the blueprint begin play, and it just says executed when begin play is called on the owning component. But if you go down to native begin play, under the native section here, I'll just search for it. Here's your native begin play, and it says the exact same thing. And it's like, okay, well, when does one fire opposed to the other? What's the difference? The difference is this one is meant to fire in code. The other one is meant to fire in Blueprint, from my understanding. When I did a test run on this, the Blueprint begin play would not fire in the code. I had to use native begin play. So that's why that's there. But really this is here for a reference anyway, because we're not really going to use it a whole bunch. The thing that we want the most is going to be the updates and the initializer for the animation. So let's do a virtual void native initialize animation. I believe I spelled that correctly. Native initialize animation. Yep. And it says the below functions are the native overrides for the phrase native initialization override point. Cool. That tells me so much about how that works. Awesome. Documentation's great. But basically this runs kind of like a begin play. From my testing, this runs first. So I'm going to go and use this more often than the other one, but since we are calling these as overrides, we do want to state that they're override. Virtual just means that we are saying, hey, down the line, if this thing that we're writing is ever inherited by something else, it has the option to override these functions here. And then I'll do another virtual void, and this is going to be the native update animation. And I can't spell. There we go. And then update animation takes in a delta time. So if we come into here, let's go look for native update. Oh, there it is, right there. This actually caught me a little bit off guard when I was looking at the documentation. So my eye is used to looking at a function written this way. Function header, braces, right? So when I'm looking at this, I'm looking at this as braces, but this is actually this. Okay, that's a little parenthesis at the end, but they did them this way. Whatever, I don't know why, but maybe just to save space. But that's what that is. But this it takes in float, and the default is delta seconds. So in here, it's going to be a float, and then delta seconds. Yeah, and now it's no longer angry, and we can go ahead and implement these. So I'll just create quick implementations. Like so. Hey, thank you all for gathering in. Howdy, howdy. What's up, Raymond guy? How's it going? Ugh, it is a Sunday. I have to go back to work tomorrow. I'm not a fan. Whose idea was it that work was a thing? Okay, so we have our constructor, we have our begin play, and so on and so forth. Alright. Let's see, what do we need here? Let's jump over to our constructor. Alright. So for this, let's jump into our begin play here. We're just going to make sure that the player is available. So RE player. So if this is not a null pointer, if it's not empty, we can then find it. So actually I don't have it running, so I can't show you. But the blueprint equivalent of try get pawn owner basically is what we're doing here. So RE player, we'll set that to cast, and we want to cast it as the type a RE character, and then we're going to do a call here, which is try get pawn owner. This is a built-in function that's part of your animation instance. If you go back into here, also if you've ever done this using Blueprint, you've seen it before, but if you're not used to doing this in C++, you can go back up and look. Where are you at? I'll just search. There he is. And this is what we're trying to get. And then you can at any time click on these, and it'll take you to the documentation page on what this does specifically. But Unreal documentation is pretty abysmal. You know, it's giving you the bare bones of what this does. So you can keep following down the line, and maybe you'll get more. But basically, this it looks back at the class, and then it follows to see what it's attached to, and gets the player controller and what its pawn is, basically. So instead of me having to get a reference to the player controller and then from the player controller getting a pawn, this says, hey, let me just go look at my parent object and see what owns it. So basically it looks outside the layers to see where the owner is. And then in here, we're going to just update the move speed. So on every tick, basically, we're going to take our player, I'll make sure he's not null. Crap. And all we're going to do in here is get the move speed of the player and set it. So RE player. Sorry. Other way around. We're taking our move speed. And we're setting it to the move speed from RE player. So RE player. We want to get character movement dot velocity. And then from velocity, we want to get the length. This is going to be a little bit mad though because we haven't exposed this from our player. So we'll save here, jump back to our character, and let's see. We want to include where's our player at? Player, that's controller, that's character, character.h. So we got that one, and then that one. Okay. All right, yeah, so this is going to go back onto the header file. So on the header of our player, we're going to add in the character movement header. So include components. Did I spell it right? Or no, that's under game frameworks. Game framework. Character movement component dot h. It actually caught it with the misspelling. That was kind of fun. Now the reason we're putting it in the header and not on the CPP file is we want the reference of this. So our animation instance is referencing our player, but it's referencing that from its .h file. So we want to make sure that it has that on there, since the CPP file is not really in its reach. But we will set the value in here. So go back to the player. Here's character. Got that. We have our constructor. Let's jump over to there, make sure we save. Let's go ahead and set some values here. So I'm going to say get character movement. And then on here, we need our walk speed. So walk speed. And we'll set this to a value. We're going to call this walk speed. Okay. We also need to set some default values for what the run speed is and all that. So I need to make this variable as well. I'm going to jump back over here under character movement, or sorry, under our constructor here. Let's go ahead and add in a U property. And how's chat going? I'm really bad at like checking the chat. Sorry about that. Okay, chat's pretty idle. All right, we got our U property. This is going to be edit anywhere, blueprint I think I'm going to do read only, and then category. What did I put this in? What did I call this thing? That's going to be under movement. And actually, let me go ahead and just do the camera while I'm here. So I'll put this one under camera. And then I'll do a forward declaration for that. This will be the uCamera component. Let's make the next one. This one will be under movement. This will just be a float. Call it walk speed. And you can set default values in your header. So I'm going to go ahead and just set these here. So I'm going to make the default walk speed be 300 F, and then I'll make the run speed be 600. So run, I'll make that 6. So if you set default values in your header, anything that's inheriting that header file will have direct access to those default values. If it doesn't need to have access to those default values, then you would do this on your constructor or in your begin play. Either is fine. I don't really need to set these here, but I think it's fun. So I'm going to go ahead and set those. I also need to add in some more movement functions. So let's add in a void, and I want this to be, so when we go from our player controller to here, our player controller is going to send the signal, hey, you've pushed this button, and we just want to tell our character what to do with that button information. So in this case, we just want to either set the its walk speed to run or to walk, either or. So I'm going to say set walk speed. And then for this one, I'll do a void. I'll call this one set run speed. And then I'll create implementations for both of these. Here's that one and this one. Inside of the walk speed, I'm just going to get the character movement component here. Where are you at? Character movement. Get. There we go. Get the walk speed. I'll set that to walk speed. And then I'll just do this down here. And we'll set that for the run speed. You might be wondering, well, why can't we just do that on the player controller, since we're just setting a variable? And the answer is you can. If I jump over to my player controller, we have our run started and run completed. So whenever we hit our run button, it'll call this function or that one. Actually, it'll call the run button to set the run speed, and when we let it go, it's going to call this one. Well, you can, if we go back to here, when we set these up. So for example, I'm just going to check to make sure the player is valid. If RE player is not equal to null. Oh, come on. Then we're going to go ahead and just call that function. So I'm going to say RE player. Now I can very much so do get character movement. And then from here, I can get the walk speed. And then I can set that, right? But I need to set that to the walk speed variable that is stored on the player. Or I could store a variable for the walk speed on the player controller. But now it kind of gets messy because the player controller would have information that we're not really sure it should have. And in order to fill this other half in, I need to basically go through this process again, right? I'll get RE player, and then I want to get its walk speed or run speed variable. So run speed. So I can totally do this, and this will fundamentally, this will do the exact same thing as calling this function. But as far as best practices are concerned, we should be asking permission to set variables on another object. So while you can do it this way, it's cleaner. It's better for encapsulation to say just set run speed. Say, hey, I got the signal, this is what you're doing. Okay, I'm setting the run speed. Cool. And then I'll do this one on here. And then this will be set walk speed. Now this does take in an F input. We don't really need the F input value. So technically we could remove this signature. But if we need it later for something else, you know, it could be important. So I'm going to leave it in for now. And I think these will be okay. Yeah. All right, so that's good there. I'm going to jump back over into the player. So we got those are implemented, those are running. What else do I want from here? Oh, in here, let's finish up the communication with this. I'll jump over to the our player over here. Make sure that I spell this correctly. RE player, move speed is the RE player, velocity, get movement component. Oh, it's not letting me do this because it's an incomplete pointer. Remember that we forward declared this, so I have to go up here and just make sure that I get the entire thing. So forward declaration just makes it a little bit lighter. So on the header file it says, hey, we have this stuff. This is what we're recommending, but if you're not going to use it, then you're not going to get it. In this case, because I do need that value, I have to make sure that I also get access to the whole enchilada, if you will. So this is going to be resident evil / characters, and then in here is the re character.h. And now this should be happier. Get character movement, and then from there I want to get the velocity dot length, and this is going to return a float. So it's going to take the velocity, compress it down into a single float value, and that's going to be our move speed. Okay. Now, you're like, well, hey, wait, why are you doing this here and not creating a function over there to do that? And the answer is, we're not setting the player's value. We're getting information off of the player that is currently active. So this is fine. I'm asking permission from that player to get access to its stuff, and then I'm passing it on to a variable on this object. So that's why. Okay, continuing on. Okay, I think that part's good, that part's good. Am I missing anything over here? I think that's okay. Okay, so now let's go ahead and set up our camera so that we can actually see stuff happening when we move. So back on my player, let's make a section, I'll call this one create camera. And this, I'm going to do the camera. We'll set that to create a default sub-object. I will put the text value in here. This just gives it a name. This is going to be camera. But inside of the brackets here, this is going to be a template, and it takes in a template of some type of object. We want the uCamera component. And we have to, because this is forward declared, we need to include that. So hashtag include, it's under camera, / camera component dot h. Yee. And then we need to set the position of our camera. Now we can just include the camera and then manually move it. There's no harm in doing that. And it's a lot easier to manipulate things visually than it is to do it through code. It's such a pain to do it through code because you can't see what's going on. But I'm going to show you how to do it through code so that you know that you can do it through code. So I'll get my camera. And now that I have the whole thing, I need to set up attachment, setup attachment. This will go to the root component. That just attaches it to the main actor inside of our blueprint. And then we want to get the relative location. So set relative location. And then inside of here, let's go ahead and set this. What did I do? I think that's a good number. Yeah, F vector. We can always adjust these later. I did -40, 0, and then 160. And that should be like that. Okay, and then camera, set relative rotation, because our camera doesn't just move in space, but it also looks down at us. So we want to set that. This is going to be an F rotator. Or if one of my former students once said, it's a frotator. That's pretty funny, so I kept it. For this frotator, we're going to do it as this can be a bit weird. So if you're not used to dealing with rotation values, so the rotator is just a vector. It's got 3 floats in it. Okay, it's a vector 3, but the the positions of the rotator values correspond. They are X, Y, and Z, but they really correspond to pitch, yaw, and roll. So if you hover your mouse over this thing, we start to set these, you're going to see, come here, you. I'll just write them in so you can see. So -10F, 0F, and then 0F. I did that backwards again. Okay. So yeah, so now you can see that these are pitch, yaw, and roll respectively. So X for the X, Y, and Z. So Unreal pitches on the X. So that's the look up and down. The yaw, that's going to go around the Y-axis. Well, in Unreal, Z is up, so yaw is actually going around Z. And then roll is going to go around the Y-axis. But that can be pretty confusing if you're not sure because of where those corresponding values are. But just be aware of that. This is pitch, yaw, and roll. And those are relative. Those rotate about a certain axis. Okay. I got those all down. We're good with that. You can save here. Let's go ahead and run this and see what we got for the movement. And if I missed anything, the compiler will tell us. I don't think so, though. I think I got it all. We haven't done anything in here yet, but that's fine. And we haven't done our interact yet. But again, that part's fine. Hey, how's it going? Welcome to the stream. I'm just waiting for this to boot. Well, waiting for it to load. Oh, we just finished setting up some stuff for our character to do some moving. Need a snack. Come on, you. And actually, while it's booting up, I have Maya, so I can show how that rotation stuff works. Let's take this wonderful object, for example. So, is it better in wireframe? Hopefully I didn't just... Okay, there we go. So here's the object. In Maya, Y is up, Z is forward, X is left and right. In Unreal, it's Z is up, X is forward, and Y is left and right. But on a rotator, you can see when I hit the rotation, you can see what axis I'm rotating around. Okay, so here's Z. If I want to make this face this way, I have to rotate around or rotate about the Z axis, which is why the handle goes around the Z, like that. Okay. If I want to rotate this so it faces forward and not to the left or right over here, I need to rotate about the x-axis. So if I grab that and go to my rotator, you can see the rotator rotates about the x-axis. So if I want to rotate facing Z, I have to rotate about the x, right? If I want to rotate facing to the right, I have to rotate about the Z. And if I want to rotate up, I have to rotate about, you can't quite see because it's green, let me go into wireframe there, rotate about the y-axis. Okay, but since in Unreal, Z is up, if we want to turn left and right, we're rotating about the z-axis, and forward is a bit different. So just be aware of your axis of rotation, and it's not too bad. Okay, so that's all in. Let me go ahead and undock this. And actually, let me go into animations. We'll go to our animation blueprint here. In order to get any of our inherited values, we need to change our class settings. Currently, we're inheriting from animation instance, but we want to inherit from our RE animation instance. So we'll do that. We'll just compile that. And then here for the move speed, all we gotta do is get access to the move speed variable. So we have walk speed. Actually, I called it move speed, didn't I? Move speed. There it is. We can get it, but we can't set it. We can just look at it. Yay. And if I hit that, that's really all we need to do here on this component. If I were to run it, oh, and you can see the camera is in place. That's a good sign. Yay. Let's take a look at in here. Want to make sure that our Jill is getting set. So the RE player, you can see, is not set there. So I'll make sure I attach. It won't let me do that here, just FYI. So this should happen in game. So when I hit play, if I get, I grab my Jill. Let's take a look. Here's my movement component. Actually, it would not be on the movement component. It's going to be inside the animator. Did I not do that yet? I did. Yeah. That should be this. That's weird. Maybe I missed something. Animation instance. Oh, I said it wrong. Let me go ahead and save that real quick. I made a goof. This should be equal to. Normally I'm checking to see if it's not there. But really I want this to fire if it is equal to a null pointer. So there we go. Sometimes you get used to doing things a certain way. You gotta follow your logic. So if you're not sure, this one where it says if the player is not, basically if the player is empty, don't try to run its code. This one is if the player is empty, make sure you go get the player. Okay. There we go. So now she's walking. Yeah, walks forward and walks back. And we can always move the camera farther back so we can see her. So we jump into her component here. Blueprint, characters, open that up. You can see that because we're writing this pretty much all in code, there's not really anything for us to do here. But you can look at, if I open up the full blueprint, jump into here, you can see the camera's been added. And it's just added to the base component here. I can take the camera and I can move this stuff, so I can move it back over here. Let's see what that looks like in game. Right, that puts me right into the wall. So instead of going back, maybe I'll go down and forward some. Or not forward, but down. Ooh, that's locked. Am I currently playing? No. Interesting. Go ahead and clear. Alright. Go ahead and exit that without compiling that. I'll go ahead and just move it in code. So come back into here. Let's go to our character.cpp, and instead of being 160 units up, let's go down to just 100 units. Now, a downside to making modifications on the blueprint, anything you do on the child gets overridden. So if you make changes on the parent, the child doesn't necessarily inherit those unless you tell it to ignore those values. Let's see if this got inherited. Character, let's open that. You can see it inherited some weird stuff. Let me go ahead and just put that back to default there. That's where it should be. So 100 is still a little too high. Let's see what 78 does. Huh. That does not look like it's doing anything. Yeah, it didn't change it. My guess is this has inherited value, or because we made changes to it before, it's like, yeah, well, you've made changes on the child, whatever not. So let me go ahead and do this. I'm gonna nuke this Jill. Bye-bye. Let's put in a new Jill. Set her to be 180 degrees. And auto possess. Okay, that's a lot better. So I can see her moving. Yeah. Cool. Her little dainty walk. Alright, let's go ahead and set up the run. She looks like a little silly, but okay. You can reset, so like if you make a change on a child object and you're like, hey, I really want you to inherit stuff from the parent and have the parent override, you can revert it. I just don't want to deal with it. Anyway, so we're going back into here, and what I want to do is, let's check chat, make sure that chat's okay. All right. How's it going? How's it going? What's up? What's up? Echo, echo. All right, so now we want to make it so that when we hit the shift key, we go into run. So I'm going to jump over to, where's our controller? Sometimes I get hair on the mouse. Weird. The cat doesn't even come up here anymore. Oh, that's the interact. That's not what I care about. Oh, we already did that. Silly me. Let's test it, make sure it's going to work. It should. But given my perplexed nature, I'm guessing that I tried and it didn't. Yeah, so if I hit shift, nothing happens, right? So that just means that we did not set up the input for it. So I'll go to my inputs, and get my mapping context. You can see we have an interact, we have forward, backward, turn, but we do not have run. So I'll add a context here, or add a mapping. Add my run, and that should be, I'll do shift. And the left shift. Save that. Okay, so now if I hit, I can run. If I let go, she goes back to walking. Whee! And of course, you could always set it up to toggle. So if you hit it, it's active, and if you hit it again, it's inactive. It's whatever. Okay, so now we're going to set up the communication between her and the little crank box. Okay, we'll save what we got. We'll jump back into the code here. Where is my interact object? Okay, so interact. Where did I put that? Grab the CPP and the header file. So when you create an interact object, so really you can create an interface using anything. It's just an actor that you attach, and everybody has a reference to that particular actor. And so when you communicate to that object, you say, hey, do you have your interface? And it goes, no. It's like, okay, well, I don't deal with you then. But if you go to another object, you say, hey, do you have an interface? I do. Okay, I'm interacting with you. Do the thing. And then it says, okay, I'll do that thing. You can do that with any object. Just Unreal Epic decided to build in a pre-built thing that handled most of that for you. And you can see up here, this class does not need to be modified. This takes in some information on their end that helps set this up for you. Fine. The part that we care about is going to be here under the I interface. So this is basically just a U object, and the U object inherits U interface and all the stuff that comes with it. The thing that we're going to modify is the I interface. Okay, and we can just add our stuff below. You can add variables here if you need to, or whatever not. All I'm going to do is make a function. So make a virtual void, and this is going to be whatever you want your function to be called, to be shared across things. You can have a thing for open door. You can have a thing just for interacting. You can have a thing for turning on a light, whatever you want that thing to do. And it's just a bank of possible things. I'm going to have this one just be called interact. And simple enough. We do need to implement this, so I will implement it. And here we are. And then I don't need to put anything in this because it's overridable. So anybody who inherits from us, they will be able to override with their own logic. Okay, and that's pretty much it. Now, if you look at the documentation for this, where is the interact interfaces? It can be a bit it can be a bit to dig into. But if you're doing just a C++ interface, you're not dealing with Blueprint, this is how you would do it. Okay, you set up your virtual because you want things to be able to modify it. And then whatever your function type is, in this case they're making a bool function, and they called it react to trigger. So if they hit it, it's going to be true or false on their return, and you can see it returns a value. Okay. This is the H side, the header file, the declaration, and then over here is the implementation. It's set up as a bool. It's just a function inside of there, and it returns a value. Okay, and then on here's the receiving object. So this is like on the player, or sorry, this is the actual. This is on the actual interface, but then on an object that would be inheriting that, you would inherit it, make sure it's a public function. It's a virtual, whatever the function type is, so the same kind of signature. that it is declared as up here, except on the child you would override, because now you're going to put the logic that you want on that child object. And you can see on the child's implementation of that, this child is called trap, so it's just an actor of trap. It could be whatever. It could be a player, it could be a door, it could be a spider, it doesn't matter. But it's going to have its own version of that interactable function, and then it's going to have whatever it does. Simple. Okay. Might be a bit, if you're not used to it, if you want this to be blueprint callable, there's some more work you have to do. You want to make sure that it is a U function. It has to be a U function. And then yet you declare it as blueprint callable, and you can do blueprint implement event, or you can do blueprint native event. The big difference is, this one, it says version of interact that can be implemented as blueprint only. Okay, so if it only needs to be modified as a blueprint, do this one. If you want to have the ability to modify in blueprint and in C++, you would do this one. Okay, so you would make it blueprint callable, and you would have it be a blueprint native event. But everything else would be the same, right? Okay, so if you want to use it in blueprint or whatever not, that's how you set it up. For us, we're just going to do a C++ setup. So this is all we're doing here, and you can see that's all I've done here, right? I have my function, and then I have my implementation. And there's nothing on mine, because mine does not return a value. It's a voided function, so I don't have to do anything here. I will save it. I'll jump over to the thing that I want to interact with, which is going to be my box. So I'll get my box here. Here we go. So on the box, I'll go to the H file, and to make sure that I'm inheriting the interact event. So include, this is going to be my Resident Evil. Where are you? I was hoping to tab it. And then I have this under system, and then RE make sure my spelling is correct. Interface. There we go. So now this is going to be inherited in here. And then this function does need to be public, so I'm going to go down to my public section. You can have multiple, by the way. You can have a public section. Usually I have one for variables, and then I have one for my functions. That way there's a clear separation, but you don't have to do that. You can have a single public section. If you're used to doing this in Unity, you might be used to doing, public and then whatever the variable name is and so on and so forth. But having sections just makes it easier, so you don't have to do that. Virtual. This is going to be a void. I'm going to call it interact. And I have to override it. Yay. Now it's going to say, hey, it doesn't do that kind of thing, blah, 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 blah. Well, we actually have to go up to here on our class declaration. This inherits from actor, so it gets some stuff from the actor class. But we also need to inherit from our interface. So I'll do a public, and then I'm going to do IRE interface. Yay. So now I'm inheriting from both things. So you can have multiple parents, right? Usually you got two. And now it says, hey, cool, but now you have to implement it. So I'll go ahead and create the implementation. Nice. There we go. So what do I want to do here? Oh, I should probably check chat and see if anything's happening, right? Okay, fantastic. So what we're going to do here is set it up kind of like we did in the blueprint version. We want to talk to the object and tell it to do the thing. Right now, the thing that we're going to talk to doesn't really have anything to do. So I'm going to set it up very simple. On my H file, or sorry, on the, yeah, so on the H file for the crank box, I need to make sure that I am inheriting a reference, or sorry, I'm getting a reference to the rotating wall. So, really, you're not going to auto-find? Make me work here. That's going to be under environments. And then RE rotating wall.h. I need to make a reference to that. So in my variable section, U property, I do want this to be editable anywhere. Edit anywhere. And then blueprint read write, because I want to be able to set it in blueprint. And then category. What category did I give this thing? I think I just have a category for interact, but I'll double check. Environment. Yeah, so I have a category for interaction. And this is going to be, do a forward. Actually, I don't have to do a forward declaration, do I? Yeah, I'm going to do a forward declaration. Class, ARE, rotating wall. And what did I call it? Rotating wall. Cool, and this is a pointer. Yay. And since this is a forward declaration, I will implement this on the other side. There we go. A couple other things we're going to do in here. We also want to set up the stuff for this interaction box, right? We need to have the boundary for us to step into it. We don't really need that, but we're going to include it anyway, just so you can see how to set it up. And then the other thing is the actual mesh object. So above all this, order doesn't matter. I just like to have things of importance in a certain order. So for like a character, the first thing for like a character would be like the character mesh, right? Or if that character has wow, my voice is getting messy. Or if that character has like a root component or whatever, I would do the root component first. You don't have to do it that way, it's just a preference. So I'll make this, anywhere did I do a rewrite? For this part, I did read only, okay. I will do and follow my past. This is going to be the mesh. Class, use static mesh component. Needs to be a pointer, and this is going to be the crank box mesh. So I'll just call it mesh. If you have multiple static meshes, you might want to specify whatever the names are. I just have the one, so this one is going to be under the collision. So collision. Okay. And this is going to be the U box component because we have a simple box collision. And I'll call this one box collision. Good enough. Any other functions I care to add? That looks about right. So I'll clear this up. Okay, I'll jump over to here. Let's go ahead and create our static mesh. So static mesh. This will be create default subobject. I'll just call it crank box. And then in here, this is going to be the ARE crank box. And then I need to set up the attachment. Static mesh. Set up attachment, and that needs to be to the root component. Now, if you're setting up a static mesh, really if you're setting up any object, you need to define a root component for it. Also, I'm getting an error because I have not declared this yet. So oh, sorry. This should be the U static mesh component. There we go. And I need to include that. Static mesh component. I also need to add in the box collider. Box component. And then every object has a root component. So let me go ahead and just define that. So root component. You don't have to declare one in the header, but you do have to define it in the constructor. So I'm going to say root component, and you can see that there's already a variable for it. This is just going to be a default subobject, so I'll just steal this. This is going to be of uScene component. I'll just call that root. Okay, and then I think I need to include my scene components. So include components, scene component. All right, got that one. Let's do our collision. And I'm gonna be lazy and just copy this. Don't be a copy paster. This is gonna be the box collision. Its attachment is also going to be the root component, so that's fine. But I want the subobject to be a uBox component. And this is going to be the trigger. Cool. I think that's all I have on the constructor. Oof. Okay, and then for the box component, a couple things extra. We did define the position and the size of the box. So I'll do box collision, set relative location. It's an F vector. And the position we did for that is, looks like 32. So we did an offset of 32, and then 0, and then 0. And then for the, we actually didn't do a scale value, but what we did was the expanse. So set box extend. And that's an F vector, 32, 64, and then 96. Is that right? Yes. And then on here, we also want to specify true. Yeah, so if I hover over it, you'll just see what that is. And the true just specifies, you can kind of see here, this is the box extend. And then if we want it to calculate overlaps, and the answer is yes, we want it to check if something's overlapped with it. Okay. Now this is not necessary to have the collision boundary, because we're going to be checking using a different method. So in the previous, we did it on Blueprint, we stepped on the boundary and we got information from whoever stepped on the boundary. We're not going to do that in this one. I have it there because we might use it a little bit more later, but you do not need it for the interaction that we're setting up at the moment, because we're going to be using a raycast instead. But it's okay. This is here in case we want it for later. And then all that looks good. For the interact, I'm going to do a UE log. And here, this is just going to be a log temp warning, and then text. And I'll just say you've interacted. Cool. And then what I want to do on here is I want to make sure that the thing that I've interacted with is also receiving information. So I'm going to say if. The other object that we have is going to be our rotating wall. So rotating wall. So if our rotating wall is not empty, yes, it really is not empty this time. What we're going to do here is we're going to access the rotating walls event, whatever event we're going to have on that object. So rotating wall, and then I need an event over there, so, or a function. I can give it an interact event, but it doesn't need to have two-way communication. So there's no reason for the wall itself to have the interface on it. So I can just set up a function for handling the rotation, whatever that's going to be. So I think I'm going to go over there real quick. I'll make a public, I'll do a void. I want to call it something different. If I call it interact, you might think this is set up using our interact system, but it's not. This is just going to be receiving a triggered event or a trigger response. So throw out a name. Give me an idea. What should I call this thing? Call it your mom? Oh. Let's call it start rotation. No, I don't want to call it start rotation, because that's going to be a defined variable name later. How about start rotating? We'll make it a declared statement. Start rotating. And be like, okay, I'll do it. I did it. I'm guilty. And I'll go ahead and just create an implementation of that. Start rotating. And then I'll make this as a U-log. I'll just steal the U-log from the other object so I don't have to keep writing these. Oh, and then on here I can get that start rotating. There we go. There we go. So I called that, and then on here, when it gets the signal to rotate, we're going to call this, and we'll just do I heard you. I heard you, bro. Cool. So with that little bit of stuff, we should be able to get the interact going and set up some default stuff for this object. So I'll save and I'll run over there. If there are any errors, we'll know in a... Oh, what is that painful sound? You are more than capable of climbing up here. I don't know why you gotta be so vocal, little miss. I appreciate you actually using the litter box. Thank you. She's gotten a bit ornery in her old age, and she will, just to spite me, pee outside the litter box. Even though the box is there, it's set to automatically clean itself. So it's a fresh place for her to go every time, and she'll pee outside the box to spite me. She'll poop in the box, but she will pee outside the box. What's worse is, like, sometimes I give her a little bit of an A for effort because she'll physically be in the box, but she'll pee outside the box. And it's not that the box is small, it's a big box, but she just... What? Yes, I'm talking about you. Hi. Are you having a hard time pooping? Let me check her for a second. What are you doing? Okay, she actually used the box. Ugh. Little brat. Okay, so we're in. We have this here. Okay, but you can see there's two overlapping boundaries. I'm going to jump into the original. Environments, this guy. All right. And we're going to remove the original stuff. So here's the cube. That can go bye-bye. And then the collision boundary. This collision boundary is 32, 64, 96. That looks right. This one... 32, position 30. Okay, that's the difference. One's 32, one's 30. I'll remove the original. So now I have the ones that's been created using code. They're right here. You can see that they're inherited. I can't delete them. And I actually can't make changes here because I have to make changes in code. And if I want to edit it, you can see here. Edit in C++. Okay. Now I can make some basic changes. I can change positions and all that stuff, as you've seen before, but I like most of my C++ implemented things to be handled in C++. But anyway, so there that is. I need to make sure that this has the static mesh, and that static mesh is rotated. There we go. Cool. So that should look the same, right? So I mean, fundamentally at its core, there's no big difference, except this boundary box. I can talk to that boundary box in code. I can talk to that boundary box in code by creating an open slot boundary and then just inserting it, but kind of like we did here, right? So like on this static mesh, this is an empty thing that I can modify here by defining that it should have a static mesh container, which is what we did, but that's open here, right? We define this one as a trigger. We can, if we don't create the default sub-object and populate it, we can just create the empty container. We can then populate it manually. So that's always an option. Yay. Okay, so now we should be able to interact with this thing. So I'm going to grab this guy. I'm going to scroll down. It should have an interacted section over here. So we have mesh, collision. You can see the collision box in that. And then we should have an interact section, which we do. And it wants to interact with the wall. So I'll specify the wall to interact with. And this is important because if you had multiple other objects in there, you want to pick the one that it should interact with. That way, this box is talking to the correct wall and not some wall somewhere else. So I'll just pick the one that's here. I only have the one, so I'll jump in. And if I were to step inside this boundary, boop, boop, and we were telling it to check for overlaps, we would get something, right? But what we're going to do is use the E key to talk to it. So we're going to set up the control for that real quick. So that's really going to be the longest part because now these two can interact, but I need to be able to tell the character to interact with it. So over here. Hey everybody, how's it going? Oh, we'll jump. Oh, did I save? Make sure I save. I'm going to go over to, let's go to the player. Character. Yes. So for the character, the way that I'm going to do it is on the character's interact function. What do I have here? Let's do a void. Now the player does not need to inherit the interactable object. Only the thing that it wants to interact with needs to have it. You can get access to that stuff by talking to the object itself, which is really handy about having interactables or having interfaces. It's a convenient way of having communication without having to really know what the other object is. So for example, the player does not need to have a reference to the wall. It does not need to have a reference to any doors. It does not need to have reference to the box or any pickup items. It just needs to scan for a general type of thing, and if it matches those conditions, then it'll fire off its executable event that we set up. So in this case, what should we call this guy's interact? I want to keep it different so that it's clear that this is not our interact system. It's just a function on the player. So I think what I'll do is this. Let's jump out, and we should have on here, see what all of our functions are. No, that's forward, that's that one, and that's that one, and those are those. Okay. Yes, I will make a function. Naming things is always difficult. It can be anything. I'll name it your mom. This is what I'll do. I'll call this one scan for interact object. There we go. Scan for interact object. Yay. Now it's implemented. And we can start setting that up. So we need a few things for this to work. Where is my stuff? Character and character H. All right. We got run speed, walk speed. That's all good. That's all good. And we got that. What other things do we need? All right, we'll start right up at the top here, and we'll include things for raycast. So I'll go ahead and get include. We need to get the world, so that's going to be inside of engine world. What else is on there? And then we need to know about the interact system. We don't have to have it on us, but we need to be able to check for it. So include, and then Resident Evil / system, and then our interface. Because when we scan the object, we want to scan and make sure that it has the interface on it. So for that, we need to be able to, at the very least, specify that that's what we're looking for. And you'll see what I mean in a minute. All right, so we'll jump down. And this is where the bulk of the work is going to be for this thing. So just get all of it so I can see what I'm doing. All right. So setting up a raycast is a bit much, but it's not that bad. So once we're in here, we want to check. So I'll go ahead and do we'll do get world. And then we can do a line trace by channel, and we want a single line trace. So line trace single by channel. Parentheses, semicolon. And then if I hover over it, you see this is a long signature. Quite a bit of stuff that goes in here. So we need a hit result. We need an F vector start location and an ending location. We need to specify the collision channel. We need to have our collision parameters set. And we need to have the response parameters. You're like, what? So all these things we can define almost directly in here, but some things we should just make our own. So I'm going to come over here, and I'm going to do F hit result, not raycast. And we're just going to call this hit result. Okay, and that's going to be the first thing that goes in here. We want a hit result. Cool. Now, a hit result gives us information back. It gives us data that we can talk to. Now, we could just pass this directly in to here, but then we wouldn't be able to receive anything off it. So that's why we're making a variable out of it, because we're going to pass this in. It's going to do some stuff, return anything to the hit result, and then we can get that out. Another thing that we're going to want is our start and ending locations. So for that, we can be really picky and define them, you know, outside of this, but really this only needs to happen when we start that scan. So it's going to take our current position and then figure out where the trace is going to go. So I'll do an F vector, and this will be the start scan. And we're going to start at the player. So get actor location. No, we'll get that later. We need the location. Cool. So we get our actor location, and then we need an F vector for where we're going. So that's going to be the end scan. And this is going to be our start location, so start scan, plus our get actor forward vector. So what that does, it tries to figure out which way we're facing, right? And we want to multiply whatever that forward vector value is by a total distance. We can just type a number in here. So I can say like 1,000 or 100 or whatever. Now, the order of operations. If you remember, please excuse my dear Aunt Sally, it should be handled multiplication first and then addition. But if you want to be very specific, because sometimes the compiler will go, I'm going to do things in order. I see we have this, and we're going to add it to that, and then we're going to multiply. So always, always, always encapsulate your math in parentheses. So when it gets to here, it goes, oh, okay, you want me to make sure that I multiply first. Yes, yes, I do. Okay. So we're going to multiply that distance and then add it back. That, I don't know if you can hear that crinkly sound, that's the cat box cleaning itself. Doing a fantastic job. So I'm going to go ahead and put that here. That's going to be the start scan and then the end scan. Next, we need to know, sorry, it's a bit loud. And it takes so long. It's on the return cycle, so it's okay. Thank you. Okay, so the next thing is our collision channel. So we want ECC underscore, and this specifies the type of collision. Now you can predefine collisions inside of Unreal. There are some default collision channels you have access to. You can use those as well. I'm just going to use the visibility channel. So I'm going to scroll down for, and there's also one for camera and destructible and all that stuff. But I want the visibility channel. And what visibility does is it checks for anything that is marked visible. If it's visible in the world, we'll scan for it. And let's see. For the fQuery params, we can specify default query params right here. So I can say default query params, wherever those are. But what you should probably do is specify your own. So, or I can do it this way. You can say f collision query params. I can do this, and then I can specify using default here. So this is okay. I'll go ahead and just hit enter there, so it's wraps. So you can do this, but if you have anything specific that you want for your query session, then you should definitely check it. So let me go ahead and just run this as it is, and if we need to make changes, we will. Same thing here for the collision response. We can use a default response. So F collision response params, and then default response params. Let's see, what else do we need? I think we got everything. Okay, so that'll give us the default stuff. Again, if you want to make these, all you gotta do is come out here and say do F collision query params, and then just give it a name. So I'll just call this query params, and then I can do whatever I want to that. I can throw on here, and then if I hover over, and it doesn't actually give me a whole lot, does it? Let's go ahead and do this. So the first part is an F name. By the way, F names usually can be entered as just text, and it still works. So I'll call this line trace. But as a practice, if something requests it to be an F name or a string or a text, in general, I try to just specify what those are, because sometimes it gets picky. Like, let me jump over to my, let's go to my interactable object real quick. Oh no, I'm getting off topic. I do that. Not you, this guy. So in here, for example, on the ulog, it wants a text object or a text macro, and it does some work with the text. If I remove the macro for this, it throws me an error. I can't just give it a string. So in general, if it specifies text or F name or whatever, I just do it inside of that object. Anyway, so I'll do F name. The next thing on the list here, so where the trace is, the B is trace complex. You can do true or false. It just means will I scan a complex object, or do I ignore complex collisions or whatever. So if you can scan anything in the world, it could be any object. It could be a statue, it could be a person, it could be whatever. Those things could have complex geometry. So you can specify true here. And then the instigator. The instigator is the actor that is calling this. So usually just put this here. And then you can specify your own. So if I don't use the default, I can use mine. So I can say query params. Okay, and that's how you can specify if you want to make your own. If you want to look up how these work, you can Google the documentation to see what your options are, because there are quite a few. Okay, so let's say we're happy with that. I also want to see my trace. So if you do this in Blueprint, it's a lot simpler, because the function that comes in already has all this stuff on it, and you can kind of look at it. You know, when you're writing it in code, a lot of those things are hidden from you, right? You have to do some digging to figure out, like the query params wouldn't show me what the heck was in it until I started writing in it, and then gave me the breakdown of what my options were. Or I can go look at the documentation. Sometimes you can hover your mouse over it and it'll give you some stuff. Sometimes it doesn't work. You know, it just depends on whatever it is and what's exposed. But if you do this in Blueprint, the function that comes with it has a thing for trace visibility, so you can see the thing in action. In code that's not there, you have to do that as a separate piece. So for that, we'll do a draw debug line. There you are. And then your draw debug line is pretty much the exact same information. Again, if I hover in here, nothing. But if I hover over here, sometimes I get stuff. So it wants the world. So we'll do get world. The next thing would be the starting and ending line. You can use the exact same thing here. So start scan and then end scan. F color. You can just do F color. And then the two colons for the namespace. And then pick a color out of here. So let's do red. And then up here, do you want it to be persistent or not? So if it's persistent, once you scan, that scan line will always stay there. If it's not persistent, then the scan line will disappear after a specified time. So I'm going to say false. And then the lifespan. The default negative is it dies almost immediately. Let's do 1 second here. And then we have the depth priority. This is going to be a unit 8, so I'll just do 0U. And then the last thing on there, I can't quite see because it's way over there. That's hover over here. Is going to be, come here, you. We got unit 8, and then the thickness. I'll do a line thickness of 1. Okay, so now if I hit the button, it should do a scan. But we want that scan to do something. And actually, let's go ahead and take a moment and just see if the scan's working. I may re-release this as a series that's been cut and edited, but I really hate editing. However long it takes to film it is at least twice that to edit it, so kind of annoying. Okay, so here I am, and if I hit the line to interact, I can't quite see, and I can't quite tell. Let's do here. As I'm hitting E, I'm not seeing a response. Let's go into system, get my inputs. The interact key is set up as the E key. Yes. Oh, you know what I didn't do is I didn't do it from the player controller. I need to call that from the player controller. So on the controller, where are you at? Let's go here. So in the player controller, we have a start and end interact. I did this as a start and an end, but we really don't need an end. We just care about the started. If you want something to happen at the end of it, you can always do something there. But for us on this, I don't really need another response. But all I'm going to do is check to see if the player is there. So I'll just steal this. And then I will call the scan function. Scan for interact object. I don't have to pass in any parameters for this because I'm just checking. I'm not using the information from the key press to do anything. If I were getting timings from the key, then I would care, but I don't really need that right now. Alright, so now, there's my line. Hey. I can't really see the thing, but it looks like it's the right height, though. Yeah, it is the right height. Cool. Now you can see, scanning off of her front there, that's going to matter. Like, if I'm facing this way and I scan, nothing's going to happen, right? But if I'm scanning here, it should work. If I'm scanning, you know, at an angle where it connects, it should work. So that's where the difference of, is it a boundary box or is it a scan? Like, how do you want to interact with your world? You can also do it based off the camera. You can have wherever you're facing, there'll be an angle from the camera, and then it grabs whatever. That's also an option. But you'd have to make sure that it doesn't scan the player, you know. I think I'm going to move the scan line up a little bit, and then go from there. So inside of the character, she's such a character. We'll take the collision. Our start location is going to be that plus an F vector 0F 0F, and then let me go up. How many units would be good? I'll do 25. And then we can see where that's going to end up being. Okay, so we're in. A little bit higher. Is that going to be too high? Because I don't want to scan over the object. Oh, it's almost too high. Now I can move the object, but I think that's fine. No, that's about the right height. It would, well, maybe it'd be a little bit higher. Here, I'll move that up. Yeah, and now I'm hitting it. Cool. Now there's no response. There's the inputs for me pressing a button, forward, back, left, and right. But we want to get a collision response out of that. So I'll go ahead and save. Jump back into here. Let's go ahead and turn off, on the player, we'll turn off these logs. Crap. I think I just have the two. That one and that one. Okay. So if our scan is good, so we can go ahead and just, I'll label this define, you know, scan info. This one is perform scan. This one is show scan. And then this one is check for the interface. So if hit results, we want to see if that is a valid blocking hit. So is valid blocking hit. So if we were successful and you know, the beam did just pass through something and it returned, hey, we hit something, then we want to get some information out of it. So we'll say we need to get the current actor. So a actor, we'll get that as the hit actor. And we'll set the hit actor to the hit result dot get actor. Okay, so we'll get the actor that we just hit, and then we'll check to see if that actor has an interface on it. So let's do this. We'll say if we have ARE interface. We'll say found interface. We'll set that to we need a cast. Whoops, come here, you. And the thing we're going to cast to the IRE interface. We will want to see if the hit actor we have has an interface. Now remember that the hit actor inherited that interface. So if I go over to, it's not up there on the list. If I go over to this object, to its H file, so remember that our crank box, it is an actor. It inherits the actor information, but it also inherits the interface information, right? So we can check to see if it's an actor or an interface, okay? Now I can't do that on this step, okay? I can't do that here because hit result only returns the actor, okay? It doesn't return anything else about the actor that I could use here. So on a separate line, I'm just going to check to see if the actor is an interface. So I'll just pass in the hit actor. Okay. So I'm just validating if there is an interface there. And if there is, then I can go to that found interface. And realistically, I could do this off of the hit actor as well, but because a actor does not have an interface in it, right? But the actor we found does have an interface on it, right? That's what's happening here. So we're going to take that found interface, and then we're going to run its interact. That's it. That's all the scan is. Yay. And if this goes through, then we should see our result, right? We should see it on the screen. It'll say, hey, you interacted with me. All right, so here we are. If I jump into the thing, and then I scan. Actually, before I do that, let's bring up this. We'll dock the layout, and we'll put the log on there. Dock the log. All right, so here's our log. And if I were to scan, so I hit, do I get information back? I did. And said, hey, I heard you, bro. And we got you interacted. Cool. So both of those connected. The box, said you interacted, and then the door, or the wall over here, gave us back a report that I heard you, right? Those are the two things we gave it. So now we need to set up the actual rotating wall. That's going to be a bit of a mouthful, though. So let's go ahead and we'll save here. I'm going to jump out of this, because what we need to do first is build the wall. So if I go back in to the environment, realistically, I could use this wall that we have I can use this and then maybe talk to it by setting up a variable that I can plug this into. That's a way to do it. It's like, how would you prefer? Would you prefer us to build the whole thing inside of Blueprint or inside of C++, and then communicate with it that way, or should we try to do a workaround? Do you have a preference? Does anybody care? Glad there's so much engagement. It's almost like my classroom. Okay, so we're gonna move on. I guess because it's interesting, we'll rebuild this whole thing in C++. We're gonna keep this stuff here used as a reference, but I think we should be good. Jump in. And I'll go to that object. Here's my wall. Inside the wall, we need a bunch of stuff. Ugh. Let's add on. We need a root component, but that's already inside of there. Let's add a U property. So U property, not a lowercase u property, a big U property. Inside of there, there should be, where we got? Wow, I can't see what I'm doing. Oh, you know what? I closed that. That's why. Okay, so I'll do edit anywhere, and then blueprint read. Did I do read only or read write for this one? I did read only. Category wall. Okay, so this is going to be the center of the wall. It's going to be a use static mesh. Actually, the center of the wall is going to be a scene component. Because remember that our wall has to rotate from the middle, right? And all the wall pieces are children of that middle piece. So this is going to be the wall center. And then the next one, this will be a use static mesh component. And then for this, let's go ahead and do the different sections. So I'll do right wall, left wall, ceiling, bottom. So right wall, could be the wrong wall. Left wall. And yeah, you do have to do the U property macro for every variable. It's a one-off. You cannot wrap it with braces. It won't let you do that. Okay. Put the next two walls down. We'll have a ceiling. And we'll have a floor. Okay. Let's go ahead and build our wall. So we'll jump over to its constructor. We need to set the root components. So set up root. So root component. Remember that the root component is already part of it. I just have to define it. Create default subobject. It's a lot of stuff. If you work in Unity, the variable names are usually smaller. Unreal's names are very, very long. But you know, the paradigm shifted. It used to be you abbreviated everything, but because now the character spaces on a variable name are quite long, there's no real reason to abbreviate. It's easier for readability if you just have it be a single line of all the things. That's why they make them super long. Anyway, this is going to be the root. And then this needs to be a scene component. So use scene component. And I need to include all those things, right? So I'm going to go over to my crank box because my crank box has all those things as well. So I'm going to grab scene component. I don't need a box component, but I do need the static mesh. So we'll jump back to the wall. Grab those onto here. Come here, you. Again, I don't need a box component, so I take that off. But those are good. So I set up the root, and now I'm going to set up walls. And I'm just going to copy this line to save us some time. Remember, don't copy paste if you don't know what you're writing. That doesn't help anybody. You're just going to get lost and get stuck. And then I'm going to have to come debug your code, and I'll just shrug my shoulders and walk away. Let's see, what do we got? This is going to be the wall center. So wall center. And that's going to be a use static mesh component. Make sure you change the name over here, because if you don't, it's going to break. So center. And we gotta have over here. There's a lot of things that go onto this wall. So wall center, we need to know where it's going to be. So set relative location, f vector. Luckily for you, because I did this already, I already know where to put this stuff. Really what you would do if you weren't sure is you'd go back and forth between the code and the program and keep nudging it over. But I already did that for you. Since we did it in Blueprint, I just went ahead and grabbed all the values from the Blueprint value and moved it over, which is handy. General bit of advice though, if you can handle it visually, do it visually. Don't write it in the code if you don't need to write it in the code. There are there are reasons you will do visual things visually, and there are reasons you'll do things that are under the hood when you need to, if you want more control. But it's whatever. For the center wall, it's 0, 0, 200. So 0, 0, and then 200. And the reason for that is, remember that our walls start at 0, 0, 0 on the grid, but we actually need the walls to, our walls are about 200 units tall, and we want that to be in the middle, basically. What else do I need? Oh, I did not set up the root component here. Wall center. That would be very bad. Actually, it wouldn't be very bad. It would just, it wouldn't be attached to anything. It would just be inside the object. It'd be weird. Set up attachment. And this should be the root component. Cool. For the next wall, let's meet our contestants. We got our wall center. Let's do this one as right wall. And I'll just change these. Everything else is good. This is going to be the right wall. And I guess I'll do this as center. No, it's fine. So right wall. There. Oh my. Yeah, this one's a scene component. Use scene component. I'm surprised it didn't flag, because this should be a scene component, yep. And I was passing in a... it didn't flag me. That would have been problematic. Okay, so we got that. Right wall, we're good for there. We'll do right wall. Set relative rotation. We also need a right wall set relative scale 3D. Okay. So before I go into too much, the right wall is negative 230 and 200. Yeah. So negative 230 and then negative 200. Yes. And the reason for that is, remember that the this is going to be in frame. So our wall is like this, the bottom of the wall is here, right? When we attach it to our object, it's going to jump up to the center, and we have to move it down from the center. That's what's going on. For the rotation, that's going to be a rotator. And inside the rotator, we did 0, 90, 0. So 0, we want to rotate 90 degrees in the pitch, or sorry, in the yaw. And then nothing else for the roll. And then for our scale, that's an F vector. Inside yaw, we did 1, 1, and then 1.1, if I remember correctly. Yep. 1, 1, and then 1.1. So there's the right wall. Here's the left wall. Now I can just, starting here, I can do a Control F and then do a replace. So the drop down, replace with left wall. Let's see. Handy. Okay. And then this is going to be slightly different on here. That's going to be a positive. That's negative. That's negative. Everything else is the same, I think. Yes. And then for the next one, this is going to be, we'll do Control F. We'll make this the ceiling. And then replace those. Ceiling's a little bit different. That's going to be 190, 220. So 190. Is that positive? Yes. $220. Oops. And that's a positive 220. For the rotation, it is 90, 0, 0. So 90, 0, 0. And then these guys are 1.25, 1. And before I go too far, the wall center is on the root component, but these all are on the wall center. So wall center. Very good. And then this. That needs to be the floor. Nice. You go ahead and just rename these real quick. Right wall, left wall. Ceiling. And floor. Okay. For the floor's position, that's a negative 200. Interesting. Wonder why I did 200 instead of 220. Oh well. Rotation is the same. Scale is the same. Okay. So that should build our wall for us. Okay, so I'm going to jump in. If I look at the wall, we'll edit in Blueprint. Okay, so it came in, and all the wall pieces should be exactly where they are. So here's the scene component. I'll go ahead and just remove the scene component. I will remove that wall, and that wall, and that wall. And then wall ceiling. And then the center. Okay. So for the right wall, I think I did that as a whole. Left wall, I had a bent wall. Ceiling and floor, I think were both straight. Hey, there we go. Not bad. So it doesn't look much different than what it was, right? So that's built, and now we get to build the rotation. Again, we're going to do that in code. It's going to be a bit different than what we did in Blueprint. Honestly, this is probably the most annoying thing, which was dealing with the rotation in code. It's one of those things that's just much, much easier to deal with visually, but it's okay. We'll go to the rotating wall. We need to define some things for our rotation. So we jump over to the H file. All right, we'll set up a U property. I'll just go ahead and steal that. We'll call this animation. Everything else is Blueprint. Yeah, I'm going to change these to visible anywhere, because I don't want these to be edited inside the code, and it should be read-only. Or sorry, editable inside of Blueprint. And then we are going to make all right. So we've got a couple rotations. So F rotator, start rotation, and then we also need an end rotation. Because we need to know where we're starting and where we're going. Because we know where we're going, but we can't say where we've been. Alright, and then what do we got here? We have a bool for whether or not we can interact. So bool can interact. Next up, we have our float curve. So if you remember, when we set up the timeline, we created a float curve that basically told it how to behave. That's what we're doing here. So class uFloat curve, and this is just going to be my float curve. Okay. Now you can do rotation float, movement float, whatever this float is doing, but we know that we're going to be dealing with rotation, so I'm just going to do as float curve. And you know, I'll do rotation curve. Let's do that. In case we have one for translation or something later. And lastly on here we have the timeline. So I'll do f timeline. What do I call this? Rotation timeline. Okay. And we're not going to do a U property on here because this is a it's a struct. So structures don't get the U property. But I do have to come up and include some stuff. So include, and this is going to be in components. Oops. Timeline component.h. Yay, and now it's happy. Okay. Now there is a spacer, so I put spaces between all the variables so you know they're independent, right? This U property only affects this guy. It does not see him. Okay. I know we need a couple U functions, so I'm going to come down to my public section for my functions, and we'll make a couple there. Alright, so U function. So U function is a macro that allows it to be caught by garbage collection, and it gets caught in Blueprint, so you can view it there. But the function that we're going to be setting up to do this requires a U function, so that's why we're doing that. So it's going to be void, and I'm going to call it rotation timeline underscore update underscore callback. So this is going to be a callback function that handles our update. I'll go ahead and implement that. And I'm going to do that again because we want to be able to handle things when our update is finished. So when it's done rotating, we want to be able to then, you know, say, hey, you're allowed to interact with it again and all that sort of stuff. So we do also need to create a finished callback. And we'll add that, like so. Yeah. Okay. Okay, let's go to our we'll go to our constructor. Rotating wall, we'll head to the constructor here. Make a new spot, set up timeline, and this is going to be what we have there. Or sorry, that's not the timeline, it's the curve. So we call it rotation curve. That's going to be new object of type f rotation, or sorry, u float curve. Yes. Okay, and then we want to specify, so inside the float curve, we specified our keyframe and the value that it goes to. That's what we're doing here. So rotation curve, we'll set that, or sorry, we want to then do what is it called? I was trying to remember it, but yeah, okay, so it's just float curve. Float curve, and then we're going to do add key. Now, why are you angry? Bum, bum, bum. Okay. That's interesting. I didn't need to do that before. Oh no, you're right. You're right. I do need to include the float curve. Where is that hidden? That is in curves, float curve, or curved float, sorry. And then add key, and then there's two values in there. You have the actual key position, so it's going to be at 0, and then the value you want it to be when it's at 0, which is 0. And then rotation curve. Float curve. Come back. It says I got an error, but I don't see where. Add key. For this one, we're doing 1.5 for the amount of time, so it's going to be 1.5 seconds. And then at that point, we want it to be at 1. Let's see. Pointer to incomplete class. UFloat curve. But it shouldn't be an incomplete class. I wonder if it's just not catching up. Yeah, rotation curve, CRVE. It's weird. Curves, curve, float.h. Yeah. Oh well. Sometimes I'm puzzled. Continue on. We're going to set the default values for our rotation. We can do that here or on begin play. It doesn't really matter. But I'm going to do it in the constructor. Set default rotation. So start rotation. That's pretty simple. It's just going to be an f vector to 0. And then end rotation is going to be f vector. It's going to be start rotation plus f vector these are f rotators. We want to add 90 to it. Yeah. Why is that one breaking? Oh, because it called the function. There we go. Oh, the sad sound of work reminding me that tomorrow is work. Okay. What to be doing next? Alright. Still not sure why this is giving me that error. This is one of those things where, like, I know, because I did this literally before doing this video, and my example project that I built, it's the same code. Like, I'm not really changing anything. So maybe there's a typo somewhere. But I don't think so. And that is a pointer. This one is not supposed to be a pointer, so that's fine. One thing I will do though while I'm in here is I'll set the can interact to a default value of true. You can do that on the constructor, but I'll just do that here. I'm really curious to see if that's really broken. Yeah, it says it's broken. It says unable to find class name for uFloat curve. Maybe my spelling's wrong. Because it doesn't matter what you put here. You know, I can, and it'll say, okay, that's a class name. So uFloat curve. It's curve float. That's what it is. uCurve float. Add those backwards. Same thing here. Ah, there we go. I was like, what was I missing? Yeah. Okay. Remember that 9 times out of 10, 90% of the time, probably 99.9% of the time, the errors are on this side of the keyboard. Tell it to my students all the time. It's probably you. It's unlikely, though it does happen, that it's with the compiler, or that it's IntelliSense, or that it's something broken in the developer's code, that does happen. But usually it's the user. For example, almost all of these up here, these are all not mine. You know, that's stuff that's happening outside of my code body. But it still compiles, it still runs, and IntelliSense says it's bad, but it's going to go. You know, sometimes it's wrong. Anyway, we want to go down to the begin play. Yes, and we'll continue on there. So in here, we have to set up our callback functions. So there's going to be f on timeline float. F on timeline float is going to be our rotation timeline progress. And that is going to go rotation timeline progress. Where are you at? There you are. And then there, we're going to set that to a bind function. Now, specifically, it asks for a bind u function. So that's why we have to make sure that the functions we're calling back to are defined as u functions. And it's going to take in this. And then the name of the function we want. Now, again, it does say it's an f name. You can just type the name in here. I'm going to come down and grab that. So there's our first one. It's going to bring update callback. Now, once again, because it is an f name, well, you got to be a jerk. It'll take the string, and it'll probably run without error. I always recommend just putting the f name on there, and then you're guaranteed that it's not going to fail. So even though it doesn't give me a little red line, I'm going to just add it. That way, if something at some point says, hey, that really should have been f name, then I don't have to worry. The next thing is going to be our f timeline event. So f on timeline event. That is going to be our finished event. So rotation timeline underscore finished event. I think that's good there. And then rotation timeline finished event dot bind u function. And then we'll just do this. I'll just type it in. How lazy do I want to be? And this should be finished callback. So a callback function is really just a function that waits for something else to happen. It's kind of like an event. It's just hanging out. It's like, yep, I'm going to be here until you need me. And then when it's time, it goes, hey, yo, do your thing. It goes, oh, okay, okay. At its core, there's not really a difference. And then we have some timeline properties. We probably could... hold on. I'll just title this. And this one is going to be... So up here, when we define our rotation curve, we're going to need some of this, right? We're also going to do some timeline definitions down here. So let's see, that's going to be rotation timeline. So rotation timeline dot add interp float. And this is where this stuff's going to really come into handy here, or come in handy. That's going to be our rotation curve. and then it wants to know the callback function. So we're going to be using our progress for here. So rotation timeline progress. Okay. So as this is interpreting the float, it's going to be updating this thing. Okay. Let's see. Get our rotation timeline again. Next, we're going to do set timeline finished function. So set timeline finished function. And our finished function is, it's just our finished event here. So rotation timeline finished event. Awesome possum. Now we want to set the timeline length and whether or not it's going to be looping. So rotation timeline dot set timeline length. Where are you at? There we go. Now our timeline, if you don't set a length, I don't really think it's going to matter, but if it's longer than your specified time, then it might not finish when you think it will. And if it's shorter than your specified time, then it might stop early or it might not run at all. So I always think it's just good to throw a time in here. 1.5 seconds, that's the maximum length of our timeline. Rotation timeline. And then we want to specify whether or not this is going to loop. So loop, we'll go down to set looping. And this will be false. Because our timeline does not loop. If it did loop or you wanted it to be continuous, you'd set it to loop. Okay, so that's the begin play, but now we have to actually do something with our functions. So I'm going to go down and we'll get our update callback. All right, so on our update callback, what we're going to do is we're going to get a rotator. So an F rotator, we'll call this new rotation. And we want to pass that rotation in from our progress event. So that's going to be fmath. And we're going to lerp this, dot lerp. Namespace, lerp. What are we doing? Start location, or sorry, start rotation, and then end rotation. And then our alpha value. We'll call this one alpha. Okay. Now for this, on our callback, we do need to take in an alpha value. So I'm going to go ahead and do this as a float alpha. But I have to fix the signature, so I'm going to go back. I'll just update that here. Okay. What's wrong with my lerp? Did I spell it wrong? I don't think so. OERP. Weird. I don't think that's spelled wrong, but I will redo it. Interesting. Oh, because that's start rotating, not start rotation. When variables are too close to the other name. All right, so we're going to take the thing we want to rotate to our wall center. So I'll say wall center, and we'll set relative rotation. And we're going to set that as the new rotation. So this is going to update based on the progress here. Okay. Let's go ahead and throw out a ulog just to make sure. So ulog. Log temp warning text rotation in progress. Just so if we get this function but it's not rotating, we can get a response back and see what's going on. And then on the callback for when it's finished, we want to take our interact button, and actually that's going to be called, where did we define that? We did. So on start rotating, we want to, sorry, I'm jumping ahead, but for start rotating, we're going to say if can interact, then we want to start rotating on the event. So it's going to be rotation timeline dot play from start. And we also want to set can interact to false because we don't want to keep hitting the button and have it spin forever. So can interact will be false. Okay, so I'm going to come back down to our finished, and inside of our finished we're going to say can interact. We'll set that back to true. So once it's done, it'll let us do it again. And then we'll do, we want to update. So every time I do a rotation cycle, so in the game, when she did the crank, it only rotated it part way, and then you had to rotate it again. So we want it to, instead of going a full 180 degrees, we want to stop, and then you hit the button again, and it goes. So I'm going to say our current start location, or our start rotation, that's going to be our end rotation. Okay, so our new start rotation is our previous end rotation. Our new end rotation is going to be our start rotation plus an F rotator. You jerk. 0F, 0F, and then 90. So we're going to add 90 degrees to our new rotation. Okay. And we can ulog this as well, just to make sure that in the event this isn't running, but it should, we can say, rotation complete. And I think that's all of it. We do need to run this on our tick. So on our event tick here, we'll do rotation, timeline, update, callback. And we want to pass in the delta time. Okay, so as this is running, as this event is running, it's getting the delta time and having it check it. And I think that's it. Let's go ahead and run. see what happens. But as you can see, like, setting it up in code is just a lot longer. It's a longer process because it's not as straightforward as the blueprints are. Blueprints, it's very visual. You're like, okay, this goes to that, that goes to that. There's a little bit more work involved if you do it by hand. Okay. It says rotation in progress. It should not be rotating. That's a bad sign. Okay. So starting off with rotation already running. That doesn't work for me. Let's go take a look. Oh, I see what I did wrong. Not this guy. Sorry, rotate timeline dot tick timeline. Delta time. That makes more sense. Oh. We're back. A dinosaur story. Oh, this dark, creepy hallway. Oh, look, a thing. Cool. Nice. And I can't spam it, right? If I keep spamming it, it just says rotation in progress, rotation in progress. Now, in the game, it rotated the other way. So see if we can change that real quick. So instead of, I mean, I could subtract minus 90, or I could subtract 90, or I could add minus 90. It doesn't matter. I'll just do it this way. Make sure I do the same thing over here. Watch it spin like a helicopter the other way. There we go. And now we can access the thing. Of course, we should set up a thing so that once it's in the appropriate position, we can't do it anymore or whatever. But really, I think in the original game, you could just keep spinning it. Even after it got to the correct position, you could probably still do it. Or maybe it said you don't need to do this anymore, but it's whatever. But that is setting this up in C++ in a nutshell. I hope you guys enjoyed it. If you have any questions, let me know in the comments. If you want to add doors or something to this and go on to the next room, let me know. And maybe we'll explore other things, like maybe setting up a menu system or something. So anyway, I'm going to hop off. Hope you enjoyed it, and I shall see you on the next round.